Alright guys, welcome back. Day 2. Go ahead and get started on your bell ringer. Okay, so when we take the limit as x approaches infinity of this guy, we're going to go ahead and divide by the biggest on the bottom. So we're going to divide everything by x squared. So I have 7x cubed minus 5x over x squared over x squared minus 4x divided by x squared. Okay. Let's go ahead and simplify that down. That gives me the limit as x approaches infinity of 7x minus 5 over x over 1 minus 4 over x. When I go ahead and take the limit of everything, this guy is end up going to give me a infinity, and whenever that pops out, my answer is does not exist, approaching infinity. So something I wanted to kind of point out that you might have seen in yesterday's notes, some people kind of saw it, some people not necessarily. So if I take the limit as x approaches infinity of a small degree over a big degree, and what I mean by degree is the degree of the x on the bottom, or of any of the x's. So for example, in my bell ringer, let me erase that real quick, my degree on the top was 3, and my degree on the bottom was 2. So if I were to flip-flop this, if I were to just completely do the reciprocal, having the 2 on top and the cube on the bottom, if I am given a problem that looks like that, my answer always will be 0. So for example, if I took the limit, I'm going to switch colors real quick. I took the limit as x approaches infinity of x squared minus 2 over x cubed plus 4. And divide everything by x cubed. Oops, x squared. There it is, over x cubed plus 4 over x cubed. The top would give me 1 over x minus 2 over x cubed. And it doesn't matter from there, because if you notice, both terms will end up going to 0, and 0 divided by anything, no matter what it is still going to be 0. Okay. The next one I wanted to talk about was when the limit as x approaches infinity of the same degree. So we both have x squareds on top and bottom. We have x's on top and bottom, so on and so forth. They're the same. That's going to be the leading coefficient over the leading coefficient. So for example, if I had the limit as x approached infinity of 4x plus 7 over 2x plus 3, I'd get 4x plus 7 over x over 2x plus 3 over x, which is going to be 4 plus 7 over x over 2 plus 3 over x. And that would essentially give me 4 over 2, which would give me 2. So if you notice, all I did was take the limit of this divided by this. So when it says leading coefficient, it's talking about the coefficient of your biggest x value that you have. And that's only when your degrees are the same. So if you notice in this one, I both have degree of 1, or I just have x. The same thing works if you have x squared, x cubed, x to the 4th, so on and so forth. They just have to be equal. And then the last one is when I have big degree over small degree. That one's going to give me does not exist, approaches infinity. Now, the reason being is just look at my bell ringer. I had the 3 was bigger than the 2. I will always get a term on top, whether it's the first term or the second term. A term, it doesn't matter. I will always get a term that approaches infinity that will cause this to not exist. So those are the 3 different types. Okay, so let's take a look at what happens when you have a square root in it. So would you agree with me that when x is larger than 0, that's when x is approaching infinity? And when x is less than 0, that's when we're going, say, to negative infinity. Logical, right? Okay. So when we're going to positive infinity, we're used to seeing x as x squared, so on and so forth. But isn't x the same thing as the square root of x squared? Wouldn't we get used, aren't we used to just going like this, going la 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 la, you're gone and you're just x? Well, today what we're going to do is we're going to manipulate this a little bit so it works in our favor. Now, when you're dealing with a negative, you're going to do with the opposite, so it needs an opposite sign. So what the heck does that mean? Well, if you take a look at this problem, right now I can't plug infinity in. If I try to do, I get infinity over infinity, doesn't work. So we're going to divide out like what we've been doing. But if you notice, I have the square root of an x squared, which is going to help me out. So on top, I'm going to divide by x, because we agree that the square root of x squared is still x. So 3x minus 2 divided by x over the square root of 2x squared plus 1 divided by the square root of x squared. Now, because the bottom here both have the same radical, so they're both square roots. If they were cube roots, they'd both be cube roots, so on and so forth. What I can do is I can bring the denominator underneath the square root with it. Because when it was the way it was prior, I couldn't simplify anything. But because they have the same radical, I can go ahead and bring it under. And now I can start canceling stuff. So if I look at the top, I see I'm left with 3 minus 2 over x. And on the bottom, I'm left with the square root of 2 plus 1 over x squared. And that still has the limit in front of it. I haven't taken it yet. Then when I take the limit through, I have 3 minus 0 over the square root of, even though it's square root, we still bring it in, so the 2 is still a constant, and that guy goes off to 0. So my answer is just 3 over the square root of 2. Alright, now I know this one looks like the exact same problem, but the difference here is that we're approaching the negative. So we're going to set it up the same idea. Limit as x approaches negative infinity of 3x minus 2 over x divided by, now we talked about how we couldn't bring it in until we divided, but we know we're going to be dividing, so we don't need to do this extra step. So I'm going to go ahead and, because we're dealing with the negative, I need to stick a negative sign on there. So negative square root of 2x squared plus 1 over x squared. So when I simplify that down, I get 3 minus 2 over x over negative square root of 2 plus 1 over x squared. And then my final answer here is 3 over the square root of 2, and that's going to be negative. So if you want to put the negative on the bottom, you can. If you want to put it off to the side, like I just did, you can. If you want to bring it top, you can. It doesn't matter. The whole thing's just negative. Okay. Go ahead and try this one on your own. I will slowly follow. So pause the video, get it started, double check your answer. So should get 2 over the square root of 5. Again, go ahead and try this one. So this one does not exist because you end up having that 4x up top. Now, what happens when you don't have a denominator? Well, what we're going to do is we're going to treat this like it has a denominator. It does have a denominator, it has that invisible 1. We're going to go ahead and multiply by the conjugate. Remember, the conjugate is almost everything the same except for the sign in the middle between the two terms. The idea is to get rid of the square root on top. So when I go ahead and do that, I have 4x times 4x, which is 16x squared. This times this is going to cancel each other out. You're getting rid of the middle terms. That's the whole point of the conjugate. So you just do the last two. So minus x squared minus 12. The square roots eventually will essentially be squared. You'd have that thing negatively squared because you have the negative of positive times negative. So this would cancel out the square root, and then you distribute the negative sign to everything. And that is over 4x minus the square root of x squared plus 12. That's still the limit. We haven't taken it yet. I'm going to go ahead and simplify it. So the limit as x approaches infinity of 15x squared minus 12 over 4x minus the square root of x squared plus 12. So all I did there was I did my basic subtraction. So now what I'm going to do is, if I plug in infinity, nothing's going to work. So we're going to divide by everything. So we're going to still just divide by x. So the limit as x approaches infinity of 15x squared minus 12 over x over, since the 4x is on the outside, it's not with the radical, it's going to still be divided by the x. The stuff inside, however, will be divided by the x squared because it's in the square root. Whew. So the limit as x approaches infinity of 15x minus 12 over x over 4 minus the square root of 1 plus 12 over x squared. This is supposed to be a plus. I couldn't figure out what that was. Okay, let's go ahead and maybe put that limit through. And I see this guy, so this means that the limit does not exist. It approaches infinity. Okay, let's try the next one. So same kind of idea. It's over 1. So we're going to go ahead and multiply by the conjugate. So this time we're going to have plus instead of minus, because we started with minus this time. So when I go ahead and multiply these through, I get the limit as x approaches infinity of 36x squared minus 12x squared minus 3 over 6x plus the square root of 12x squared plus 3. Go ahead and simplify that top. So I get the limit as x approaches infinity of 24x squared minus 3 over 6x plus the square root of 12x squared plus 3. So next up, one too many, sorry about that. So go ahead at this step and start dividing. So 24x squared minus 3 over x over 6x over x plus the square root of 12x squared plus 3 over x squared. And if you notice when you start putting your limit through, you're going to get does not exist again because it approaches infinity. Not all of them will be like that. Your homework definitely will not all be does not exist. You will get actual numbers. I promise you. Speaking of your homework, there it is.